Hello everyone, welcome to the session number 4 of the 5G Massive MIMO training. As you remember, we had covered very important concepts and details in the first 3 sessions where we started with the MIMO introduction, which was covering both MIMO and Massive MIMO basics. We started with comparing with the different antenna solutions, including passive antenna and active antenna and much other details. So you can refer to this session if you would like to get a very good basics before diving into the details. The second session also we had went through a very high level introduction about the massive MIMO in general and also some important features such as single user MIMO, multi-user MIMO, and also the beamforming in general. Then the session number 3, we had went through a deep dive through the beamforming details and what kind of channels being supported in 5G massive MIMO compared to the 4G and how the beamforming is being implemented in different channels or reference signal, including the SSP, and also including the CSIRS and the physical downlink shared channel. So let's show you the details where we are going to cover today and just to quickly show you what we have introduced in session number 3. So this is actually the content of today's video. As you can see, whatever strike through this has been covered in session number 3, which was really very intense one and covered many important details. So in today's video, we are going to focus as a continuation for the previous session, where we were covering the PDSCH beamforming, which is related to physical downlink shared channel beamforming. In previous session, we had covered the part related to the codebook based. This session will be covering about the channel reciprocity or the SRS based. And on top of the SRS base, we are going to go through also the beamforming for the PDCCH, and also we'll be covering multiple other important details such as the SRS functionalities in general, what is the UE antenna switching means, why we need UE antenna switching, how to check the capability, and what is the related SRS, for example, shortcomings or disadvantage, and how we can optimize this kind of disadvantage or shortcoming, in other words, for the SRS. We'll go through all of that. Then we'll be also ending by showing the different type of SINR signal to noise ratio used in the 5G compared to the 4G. So let's move forward to see what we have today. So as we had highlighted, the first part we are going to start with, it's about the SRS based or PDSCH beamforming based on SRS, where the GNB can calculate the weight and can generate the beams of the physical downlink shader channels based on the SRS estimation. So first, first of all, let's before being or explaining this kind of information here, let's just recover or recap what was the main functionalities for the SRS. So as you can see from this figure in the left, let me zoom in first here. This is the main functions for the SRS channel reference signal, which is called sounding reference signal, which is usually being transmitted in the uplink direction by the UE, and the GNB can measure and estimate multiple things through the SRS transmission. So the first thing the GNB can estimate, which is about the uplink channel aware scheduling and link adaptation. It can do in general the link adaptation for the uplink based on the SRS transmission. Link adaptation, for example, means that it can estimate the signal to noise ratio, SINR, for the SRS, and it can define what kind of MCS required to be allocated for the users, what is the best resource blocks to be allocated. So all of this can be done through the SRS, and GNB will be measuring the SRS and estimating all of that, and accordingly it will be implementing the link adaptation. The second part, which is actually the main our focus today in our session, is related to the downlink propagation channel estimation. That, as we mentioned, it can be used, the SRS, by GNB to estimate the downlink channel propagation to be able to generate the beams of the physical downlink shared channel, or in other words, the traffic channels. So how this can be done, we'll explain this one shortly. But first of all, as you know, SRS, sounding reference signal, can be used for downlink channel propagation only in the TDD, time division duplex, because in TDD we have the same downlink frequency, downlink and uplink. We have the same frequency used for both downlink and uplink, but in different timing or different time intervals as a transmission point of view. So, for example, the uplink frequency can be used to estimate the condition uplink frequency can be used to estimate the downlink propagation channels. However, this requires multiple information or E capabilities. Will be going through that part. The next three parts actually will be covered in the next session related to the uplink beam management and something called non-code book transmission and code book transmission. This is more about uplink beam management in general and uplink beam forming, including the PUSCH, which is the physical uplink shared channel, and the beam management in general. So this will be covered in the next session. So now let me explain in the steps how the GMB will be evaluating the beam forming of the traffic channels based on SRS. So initially, the GMB, as you can see in the figure in the right here, the GMB need to first of all transmit or send in the downlink direction using the RRC reconfiguration message all the SRS related configurations. There is multiple parameters and configuration need to be delivered to the UE to instruct them to transmit how to transmit the SRS in general. Like for example, to be periodic or aperiodic. This will be all discussed. What kind of frequency being used or not. This is all we discussed about the parameters. But the first part here, the first point must be done from GMB to the UE. Should deliver all the related SRS configuration to instruct the UE of how and when and where to transmit the SRS. Then once the UE receive the information, it will be start transmitting an SRS in different ports, as you can see here, and different something called SRS resources, so or SRS resource set. All of this will be explained as well in next slide. So the UE will start transmitting the SRS. Okay. And one of the, just to also remember you that one of the, to recap, the SRS usually is transmitting over the complete bandwidth. It can be, for example, over, if you assume you have 100 megahertz, so it can be transmitted over the 270 RBs. The UE will be transmitting the SRS over the full bandwidth. And this is also, you can control it. We'll explain this part in more details, but it must be transmitted over the full bandwidth. So assuming now the UE start transmitting the SRS in uplink direction, so the GNB will be now able to estimate the pre-coding matrix for the downlink traffic beam forming. So here is the GNB will estimate all the pre-coding matrix and downlink channel propagation through the SRS transmission. And once estimate the pre-coding matrix through estimating the downlink channel propagation, it will now start transmitting the traffic channel uses the calculated pre-coder from the downlink channel propagation estimated from the SRS. And sometimes, or most of the time, afterwards, they will need to report again based on the rank indication CQI, which is, as we highlighted earlier in the previous session, that this can be estimated based on the channel sounding reference signal, which is the CSIRS measurement, or in general, it can be estimated even based on the downlink CSIRS, as we highlighted in the previous session. So the UE will report afterward the rank indication CQI. But the main question you might ask yourself, what will be the use of the GMB to use this kind of information, including especially for the CQI, channel quality indication? Actually, one important point I would like to highlight it, which is written in the bottom right here. You can see here it's mentioning that whenever or when using the SRS in combination with the channel reciprocity to estimate the downlink channel propagation, you should know that it should be recognized or recognizes that SRS measurement do not quantify the downlink interference conditions. What it means by this, for example, if there is an interference being generated in the downlink direction, for example, as you know that we have this CSRS and so on, transmission, if there is a downlink interference being there due to the very edge users and multiple overlapping, this will not be estimated in the SRS. So this might be a risk that it might be inaccurate feedback. So the calculation of pre-coding matrix might be inaccurate kind of, right? So in this case, the GMB can do one of two things. can use the CQI information just to do a fine tuning for the pre-coding matrix, because at the end CQI is measured based on the CSRS. And if you remember the CSRS, we used to have different types of CSRS, including the interference management and other types as well, which was measuring the intra and intercell interference. So based on that, the CQI will be reported by the CSI channel state information. So if the GMB received the CQI information, it can later on do adjustment for the physical downlink shader channel in case if the interference was there and it was not being qualified by the SRS uplink feedback. And the other action can be done. It can be switching between the codebook based, which we have discussed in previous session, and the SRS. For example, JNB can make switching to decide to use the CSRS, which is a codebook, instead of using the SRS to estimate the downlink channel propagation. For example, if the user moves to the very edge, you have a limited coverage, you have a problem in reporting the uplink, for example, SRS in the uplink direction due to limited power and so on. And also other case, as you highlighted, there might be an interference. So in this case, JNB can instruct the user to start reporting the PMI based on the codebook, as you highlighted in the previous session, instead of using the SRS. And all of this can be you can check or verify from the layer 3 messages when the GMB is using or instructing the user to use a codebook or to use a channel reciprocity, which is SRS. So this was covering all the information you need to know about the channel reciprocity, which is the SRS based to calculate the pre-coding matrix, which will be used for the PDSCH beamforming, as you can see here, as we have highlighted. But important point to highlight that the estimation of downlink propagation channel, when a channel reciprocity exists or used, the BTS need to use the kind of information for its downlink transmission as written here. Okay, towards the UE. Like this, it needs some information. And these kind of information are categorized into two general categories for downlink channel sounding using the SRS. For example, if the GMB, you want to estimate the downlink channel sounding using the SRS, sometimes there is two categories. First of all, the UE itself as a capability, assuming that we have equal transmission paths equal to the receive paths. For example, you have two transmitter and two receiver, which is called 2T to R. In this case, there is no any capability required from the UE because at the end, it's GNB, which is a very important information as well, need to understand what is the current condition of propagation channel from the receiver, not for the transmitter part from the UE. For example, it needs to know what is his receiver condition, what is the propagation channel, what's the radio condition for each of the receiver. Assume the user have 4 receiver, 4R or 2R, so the GNB need to know this kind of things. You need to know the downlink channel or radio condition for the receiver. And as you know, that in general, the SRS is being transmitted in the uplink using the TX, which is the transmission paths. So the TX should have use the job of using the TX paths to transmit the, as I mentioned here, the SRS using each of the receive antenna. For example, if you have this figure, as you can see here, let me first get it here. Yeah, this figure in the bottom right here. I'm going to zoom in here. For example, assume here you have only one transmission, which is the SRS transmission here, and one receiver. So the GNB, the UE will be using will estimate or send the receiver to switch it using as a in the transmission side. So you have one transmission and one receiver. So the SRS will be transmitted directly using the one SRS because you have one transmission, one receiver. So you don't require the so-called antenna switching. I'll explain antenna switching shortly. And here, for example, you have two transmission and two receiver. So directly one transmission is linked to one of the receiver of the UE, and the other also is linked to one transmitter. The second one linked to the other receiver. So directly the user will be transmitted to SRS in the uplink direction, and GNB will directly be estimating that part. And this also assuming the scenario where we have 4 transmission and 4 receiver. This means you have 4 transmitter and 4 receiver. Each transmitter will be linked with 1 receiver. So in this case, also the UE don't need to do any switching. I'll explain that switching, but switching will give you also more clear explanation about that part. But in general, this part, which is you have equal transmission and equal receiver at the capability from the EU side, doesn't require this so-called concept antenna switching. This case, just directly the whatever SRS being reported can use directly by the GNB, and it doesn't require any capability or information to be sent from the UE to GNB. So in this case, it's being directly. Just GNB will know that this user having equal transmission receiver, so it can activate the or instruct the user to report the SRS to start doing the downlink channel propagation. The second one, which we be explaining in more details, that in case if you have, let's assume, less transmission paths in the UE and more receiver paths. For example, you have 2 transmitter and you have 4 receiver. In this case, GNB need to know the condition of the 4 receiver, right? So assume that the UE is only transmitting from 2 paths, like two SRFs. So in this case, the GNB will not know all the radio condition of all the 4 receivers. So it cannot have an accurate estimation of downlink channel propagation, correct? So in this case, there must be something called antenna switching, where the user will switch each of the transmission paths. For example, transmission path TX1, it will switch between 2 receiver to send 2 SRS feedback. Then the second path as well, it will switch between the other 2 RX, 2 receiver, to send additional 2 SRS feedback. So in general, it will be 4 SRS transmission in different, for example, antennas. It will be sent 4 times 4 SRS. So the GNB will estimating the radio condition for the 4 RS, for the 4 receiver. So it can estimate the downlink channel propagation. So it can do accurate measurement and accurate estimation, so it can estimate the pre-coding matrix. I'll explain this one part in more details in the next slide as well. So what is the shortcoming or kind of risks we have in the SRS in general? If you look into the figure in the bottom left here, we have, first of all, as you know, reciprocity base is only supported for the TDD. This is, we already highlighted about that part. The second part, it's about the limited uplink coverage. As you know, that the UE in general supporting 23 dB or 26 dB as a maximum, right? Plus, the SRS doesn't have any error quantization compared to the physical uplink channel and all the other channels. I have explained this in the previous session. You can watch the previous session to understand this part more. And the third part, that as we highlighted before, the SRS, as you can see in the figure in the right here, the SRS usually will be transmitted over the complete bandwidth, right? Which means that it will be the power of 23 dB or 26 dB will be distributed over the complete bandwidth or complete subcarrier spacing, subcarrier resource element, I mean, for used for the SRS. This means you will have less power per resource element because you have a bigger bandwidth and the power is distributed over the full bandwidth. So this is can be a limitation, especially in the very edge. So in this case, you need to do something. There is an optimization can be done. I will be showing this with the parameters, 3G PP parameters. I will be showing this what kind of parameters can be used, and also other solution that you can switch between the codebook and the SRS based on the uplink or the SRS SNR. I will explain this part as well. So this is one of the limitations related to the UE coverage, that the UE coverage must can be limited because of the UE power and the edge users as well. The third part, it's about the limited UE capabilities itself. That as you highlighted, this is in many cases, whenever you have the transmitter paths in the UE side less than the receiver paths, so this is require UE capabilities. So this is also limiting the channel reciprocity in general. But this part more related to UE capability. The part number 4, which is related to the SRS resource availability. First of all, whenever you have more RC connected users, so all the SRX resources can be utilized. So some users might not be able to transmit the SRS because of the resource limitation. But in all cases, the SRS as a resource limitation is like I said, is much better compared to the codebook. Codebook like have a finite number or a limited number of codebooks, so it kind of have more limitation in terms of PMI being used and so on. While the SRS, yes, it have a limitation, but also there is some optimization techniques can be applied to improve the capacity. I will explain this part as well. Okay, this is the part first related to the antenna switching, right? As I highlighted, there is something called antenna switching, which is a capability required by the UE to sound or to transmit the SRS for all the receiver. Again, let me try to explain it with more visual examples to try to make it more clear for you. First of all, as you know, this example is assuming you have two transmission and four receiver at the UE side. So as you can see here, you have transmission one, TX path one, TX path two. However, you have four receiver, right? So GNB usually, if the user transmitted only two times, so this means he will only transmitting the SRS using only two receiver, for example, one and two. So GNB will not have all the information about all the receivers, which is more important for the downlink, right? Because at the end, whenever the downlink traffic beams is going to be transmitted, will be received by the receiver, right? So the GNB need to know all the condition about that part. In the normal case scenario, whenever you have transmitter equal to the receiver, so each of the transmitter will be linked to the receiver, so the UE can transmit directly the SRS, and the GMB can estimate directly the propagation channel of the downlink. Okay, but in this particular case, you must have this concept which is called antenna switching, and it requires a specific UE capability. I will be showing how to check this from the UE capability message in the next slide as well. So how this works, as you can see in this figure, here it's assuming that the symbol number one or symbol number A, the two transmitter which is being used by the UE having two transmitter is being linked to two of the receiver. So the first SRS feedback in the uplink direction will be sent, for example, in symbol number A to the GNB. Okay, but the GNB still need the other information about the two other receivers. So there must be this kind of concept called antenna switching. You can see in the second symbol or second symbol, this cannot be done in the same symbol. And the second symbol, as you can see here, the the second pair of receive antennas has been switched to the transmitter one, right? So you can see here the first pair here, this one and this one was using the transmission. Then the transmission or the TX part is being switched to the second one, and this will again reporting another SRS resource to the GMB in the uplink direction. So the GMB in this case can estimate all the receiver radio condition here, so it can estimate the pre-coding matrix, and it will be more accurate now because it have all the knowledge about all the receiver, so it can easily estimate now the downlink. This is the main concept of the antenna switching and why we need it and why it's must requirement for the users which doesn't have equal TX and RX or transmitter and receiver. That's why it's must. Let me quickly give you another feedback about some of the parameters we're going to discuss. First of all, as I highlighted in the very beginning, that initially the GNB must send some of the configuration to the UE to instruct him how he's going to send. So one of these information, something called SRX resource set ID. So under this resource set ID, there is multiple parameters. For example, here we are highlighting that you have SRS resource set ID. And here it's highlighting something called usage, something called antenna switching. So whenever the SRS resource set ID having this usage equal antenna switching, so the UE will understand that this antenna switching, I need to switch between my transmitter, between different receiver, because I need to transmit the SRS to the GNB, which is going to use this feedback for the downlink propagation channel and for the traffic beams beam forming. So this is how it's telling, it's instructing the UE or letting the UE knows when to switch his antennas from the transmitter to different receiver. The second part, it's about the resource type within the SRS resource set ID. It's telling him whether to report this one based on periodic or aperiodic or semi-persistence. For example, periodic is usually based on a fixed interval. Let's assume that the user is usually sending the SRS every 20 millisecond, 40 millisecond, depending on your configuration in the network. So he will know what is the period, for example, 20 millisecond and so on. Other information is about where which symbols, what is the symbol locations, and this kind of information also included within the same report, as I will explain in the next slide as well. One more thing, very important thing, as highlighted here, you need to have two kind of switch, right? So in this case, you have two transmission and four receiver. So you need to have two resource set, right? Each one of those resource set, SRS resource, not set, sorry, SRS resource ID or SRS resources, you need to have two SRS resources. Each SRS resource will have a different parameters, which is telling the UE also when to switch and what kind of resources is going to be used. So for example, as I highlighted, this resource set ID will includes two SRS resources, resource ID 0 and resource ID 1. And the first SRS resource corresponds to transmitting the SRS from a first pair of receive antenna. This pair, antenna 1 and antenna 2, this is the first pair. And the second SRS resource, which is SRS resource ID, this is corresponds to transmitting the SRS from the second pair of receive antenna, which is this one and this one. So here he understand based on this information you send to the UE in the RR serial configuration message, you will understand how to transmit the SRS in the uplink direction. And one very important concept as well, sometimes based on the configuration of the network, there can be sent two SRS resources to the UE in the RRC configuration message, and both of them using the same ID, which is 0. However, this must have a different resource type. For example, the first one having periodic, which means the UE will understand he needs to transmit the SRS every 20 milliseconds, while the second one is telling him also we will instruct you based on aperiodic reports. For example, this is why this one is used. The aperiodic is used like or set by the GNB with aperiodic reporting. So the BTS or the GNB in general can request additional transmission whenever necessary. For example, you know that there might be a change or the GNB need to update the beams, beam forming weights and so on. So it can use the aperiodic, can instruct the UE to send the SRS based on this DCI report. So as you can see here in the figure in the left, where I added here, you can see that we have different type of resource type under the SRS resource set. As I mentioned, you have two different now SRS resource set ID 0 sent twice. One was periodic and one was aperiodic. The aperiodic one, it will be based on the DCI information. Whenever the GNB needs information from the UE, it will instruct him through sending PDCCH, which is including the downlink DCI information, requesting the UE to send the SRS instead of waiting for a specified or fixed interval to transmit, which means the periodic one. So here I would like to show the one more example, which is more easy one, for the scenario where we have one transmission and two receiver capability of the UE. So you can see in the free center here. So this is how the antenna switching will happen. During symbol A, the user will be using this transmitter to send the one SRS to sound the receiver radio condition here and send it an uplink to the user, to the GNB. Then the second one is to switch the SRS transmitter to the second receiver. So this is in the second resource set ID, resource ID 1. It will be do the switching and send it to the uplink. Okay, so this is what I would like to say about the antenna switching. And last important information that typically UEs requires at least 15 microseconds to do the switching between the antennas. So this means what? This means that sometimes or most of the time there is at least one unused symbol between the transmission when using the 15 or 30 or 60 kilohertz subcarrier spacing, or two unused symbols between the transmission when using the 120 kilohertz subcarrier spacing. Again, it requires at least the typical use 15 microseconds. You can do the calculation of the requirement or the duration of the symbol based on different subcarrier spacing. So this was the last information I would like to deliver about the antenna switching. Now let's move to the next part where we will explain how to check the UE capabilities requirement for the antenna switching from the UE logs. This is actually I had quoted the from 3G PEP, the figure on the left, which is explaining the parameters where you need to check in the capability. In general, let's just to give a simple explanation. If you went and checked the e-capability message, you'll find under the supported band combination list, you'll find something called SRS, supported SRS T export switch. For example, here is mentioning 2T or 2 transmission and 4R, which is 4 receiver, mentioning that the user is supporting, in this case, the transmission, the antenna switching for this particular capabilities, which is 2T 4R. Okay, this is how we can check the capability in general from the UE message. So you can do some insights for your network to see how many users supporting the capability or not. Because in some cases, you might found based on the KPIs we have that, for example, you have less utilization of the channel reciprocity or the SRS. So this might be related one of the reasons for the capabilities of the device. So now I would like to cover two parts actually here, or the remaining two parts about the SRS in general. First of all, how you can know from the UE logs whether the GNB is instructing the user to use, or the GNB itself is deciding to use the channel reciprocity, which is the SRS feedback, or the code book to estimate the traffic beams or to calculate the beam weights for the beam forming of the downlink traffic channels. How this can be done, or how you can get it from the UE logs. We had explained already about the code book, how to check it from UE logs. Now I'm going to explain about the SRS. For example, if you look into the figure on the left here, this is from layer 3 messages. You will find, first of all, something called SRS resource to add mode list. So you'll find under this one, you will have different SRS resource sets. You can have up, I think, to 16, if I remember correctly. For example, you can have the GNB can configure the user to use different SRS resource sets for different of multi purposes or multi uses or functions. Okay. For example, in the example I'm highlighting here, under the SRS resource set, there is multiple parameters, as you can see in this table on the right. Something called resource type. This is just telling him that this SRS resource set is going to be periodic, every 20 millisecond or whatever, or aperiodic or semi-resistance. Okay, this is the type. And what is the usage? And this is the most important. Usage is telling him the feedback you are going to send using the information in this layer 3 messages for this particular SRS resource set ID. This is going to use, for example, for beam management and uplink. I'll explain this one in the next session, or codebook or non-codebook. This will be explained in the next session, but it's more about the uplink beam forming. The last one is about the antenna switching. So in case if you open your message in the layer 3 messages from drivetest and you found the usage is set as antenna switching, then here you will understand that the downlink beamforming calculation will be based on the channel reciprocity, which is the SRS feedback. Otherwise, if it's not indicating anything, this means you need to check the other one, RSC configuration, as we explained in the previous session. You will understand that in this case, the GNB is going to use the code book instead of using the non-code book, which is the channel reciprocity or the SRS. Okay, so this is the first part. The usage will be as antenna switching. The other parameters, which is alpha and P0, this is actually related to the uplink power control parameters. Can be explained in different session, but it's not. It's related to actually optimizing the uplink radio condition or interference, but this is not directly related to whatever I want to discuss today. This can be explained in different session for the uplink power control in general. You can drop a comment if you would like me to go through the uplink power control in general. Under the SRS resource set, you'll find different SRS resources. As I highlighted, you can find one or two SRS resources, as you highlighted in the previous example about the antenna switching. So assume now you find SRS resource set ID, SRS resource ID, not set. Under the resource set, you'll have SRS resource ID 0. You can have also SRS ID, for example, 1. To SRS resource ID, so 0 and 1. So here is the information only for 0. This is just telling him how many ports is being used by this SRS resource, and something called transmission comp. I will explain this one because can be used to improve the capacity of the SRS. I'll explain this part in the next slides. about the parameters, and also about the resource mapping. This is parameters. It's just telling him the position of the transmission. When is the UE is supposed, when and where he's supposed to transmit the SRS, at which symbol, and for example, the what is the start position and so on. So this is just telling him about the information of the time and frequency domain. The last information you'll find under the SRS resource is related to the frequency hopping. Frequency hopping usually is being used if you would like to move or to overcome the uplink limitation of the UE. Like if you have uplink limited power and you have a problem in the uplink coverage, so you can use the frequency hopping. I will explain this one as well in details. But in general, to summarize, if you would like to check whether the GMB is going to use codebook or non-codebook. Non-codebook means the SRS, which means channel reciprocity. So you need to check the SRS resource set usage. If the usage is set as antenna switching, this means GMB is using now the SRS to estimate the pre-coding matrix for the downlink beamforming, downlink traffic beamforming. Now let's move to the shortcomings. For example, we highlighted that we have one of the shortcomings, which is uplink limitation of the power, how we can optimize this, and what kind of parameters as the 3G PEP parameters can be used to optimize this kind of limited power. And the last part will be ending about the SRS is about the capacity. Whenever you have a capacity limitation, how also you can tune the 3G PEP parameters to optimize the capacity of the SRS. So this is actually the part about the shortcomings of the uplink limited power of the UE, which can impact the SRS transmission. So how we can tune the parameters we have to try to kind of improve the power or increase the power in the uplink direction. Okay, first of all, I highlighted in the very beginning that the usually SRS, as you can see in the figure, in this figure, the SRS is transmitted over the fault bandwidth, as you can see here. So the power, which is the UE power, which is 23 or 26 dB, will be distributed over all the SRS resources, right? So this means the very edge will have a coverage limitation. So there is a solution actually, which is a SRS frequency hopping, which can divide the transmission into different symbols. As you can see here, for example, in the right figure here, the bandwidth split it into two halves. So the first half, the UE transmitted at symbol 0, for example, this is symbol 0, assume symbol 0 or whatever the symbol, transmitted the SRS at symbol A, the half of the bandwidth. Means that now instead of distributing the power over the complete bandwidth, you will distribute the power over the half the bandwidth. So this is even can double the power, right? You can have 3 dB gain. But still, there is the GMB need to know the information about the complete frequency band. Otherwise, it will have a limitation. So that's why we have this kind of concept called frequency hopping, that the UE will transmit the SRS over two samples, for example, in this particular configuration. You have multiple different configuration you can reconfigure, but this is a common one, the most common one, which is usually used by the implementation or vendors or operators or whatever, to split the bandwidth into two bars and make the frequency hopping through transmitting the SRS two times in two different samples. So the first sample will have half of the bandwidth, the second samples will have the frequency hopping and at the second of the bandwidth. So the GMB now can have the information about the full bandwidth and at the same time of the SRS bandwidth, and at the same time the user can increase the power of the transmitted SRS, so it can improve the uplink coverage. But there might be a trade-off of that assuming that you have a very high variation of the channel, user is moving very fast and so on, so this might be a channel aging problem, as I have highlighted here. For example, a channel aging means that if the SRS is scheduled in intra-slots, for example, assume this is within the same slot or even intra-slot frequency hopping. So if the channel is varying very fast, this means the estimation of the first, or just one, SRS transmission may not be valid anymore. It might be outdated. It might be inaccurate anymore because if the user is moved, let's assume it was very good. The user moved to bad radio condition, become very bad. So this means become outdated. So this can cause a problem. So actually there is a different thinking or things you can think about it. For example, usually some of the vendors can do it a dynamic, not a fixed configuration. This is based on two parameters. I'll explain them shortly, but in general, vendors can make it based on dynamic way. For example, based on usually they make it based on SRS SINR. If the SRS SINR is very poor, so it will do the hopping. It will enable the hopping. If the SRS becomes good, so it will disable the hopping, so it will keep the transmission only at one particular symbol. This can be one way around to try to optimize in general the hopping instead of doing fixed configuration for the user all the time. So in this case, if the user moved from battery to radio condition, so there will be a change in the configuration. So the user will understand he don't need to split the transmission over different symbols. Okay, this is one of the things. Second, you can think, for example, for the fixed devices, in case if you don't have this kind of a dynamic change. For the fixed device, assume fixed wireless access network (FWA). You can, for example, allow them to use the transmission over the half of the bandwidth all the time, different frequency hopping, because we are not expecting to have a high channel variation because at the end the user are at static location. One last part to highlight that we have a different combination or parameters, two parameters to control the frequency hopping, but usually the vendor or the implementation can do you make it based on switch or specific thresholds and so on. But just to explain the standard itself, you have something called BSRS and something called MSRS. This is two parameters. For example, the BSRS, which is BSRS 0, this is the default one, which is you transmitting over the complete bandwidth. So if you change this BSRS to 1 or 2 or 3, as you can see, for example, BSRS 1, so this will split the bandwidth over two symbols. And for example, instead of 128, it will transmit 64 resource blocks. And the second symbol, it will transmit the 64 symbols. And you have a different combination, as you can see. This is actually a large table. You can find it in the 3G PEP, this one, which is highlighted here. So for example, here, the BSRS 0, 1, 2, and 3, and you have the MSRS. This is the combination where you have it in the 3G PEP. And the SRS in general can be transmitted even across four symbols, not only one or two or three, even can go up to four symbols. So that's all about how to kind of overcome or at least improve or mitigate the limitation of the uplink UE limited power in the uplink direction, and this can improve the SRS coverage and accordingly can reflect in the improving the downlink user throughput. Now let's move to the last part about the SRS, which will explain how to optimize the capacity point of view. Before going to the last part, I just to highlight to you, if you would like to check the configuration, again from the same message highlighting the layer 3, you can see this frequency hopping. You have these three parameters, which is from the 3G PAP, which is CSRS, BSRS, B hopping, and this is you can map it with whatever table I have explained here. The last part, it's about how to optimize the capacity point of view. There is different methods. Vendors can have different implementation. For example, they can decide when to activate the SRS for the user in general, based on whatever conditions. Each implementation can have a different thinking about it. But I'm just trying to explain here from the standard point of view. If you would like, for example, to increase the capacity, assume that you have site with heavy users, have many RRC connected users, and you have a limitation in the SRS. So you would like to increase it. So in this case, for example, you have something called transmission comb size. Transmission comb size, this is something more in the 5G. It was not like it was, we have, I think, fixed configuration in the 4G. But you can see here, transmission comb size equal to, you have two types, 2 and 4. 2 means that the user or the UE will be transmitting the SRS in each every second subcarrier, as you can see here. The first one transmitted here, then moved here, and kept like this one. And the transmission comb size 4, this means that transmission will be in each fourth subcarrier, as you can see here. 1, 2, 3, 4, then it's being transmitted here. So it will be keep here. So this means what? First of all, this is increasing something called the CF, which stands for cyclic shifts. Like for example, in transmission comb 2, you have 8 cyclic shifts. This means you get 8 users can share the same resource element. So 8 users can multiplex within the same resource element. So you can here have 8 users at this one, for example. Once you change it to COM size 4, you have, first of all, available other SRS can be used by other users, which is the one in between here. Or now you have more cyclic shifts. This means you can multiplex 12 users within the SRS. So 12 users can send the SRS within the same resource element or the same transmission. So this is increasing the capacity of that part. But again, the trade-off that in this case, if you are sending, you are transmitting in each fourth subcarrier, this means you are almost transmitting over the half of the bandwidth, right? Or at least less compared to the previous. It's almost half compared to this part. So the GMB can have a less information about the complete frequency in the bandwidth. So you can, this can be the trade-off. Sometimes can make inaccurate or not incomplete. I'm not going to say inaccurate, incomplete information about the complete bandwidth. So this is how you can, for example, think to improve some of the capacity limitation scenarios. Now let's move to the last part about this session, which related to the physical downlink command control channel beamforming in 5G. The PDCCH beamforming or physical downlink command control channel beamforming, again, as you highlighted before in the session number 3, this was not available in 4G. It's just supported by the 5G. So PDCCH beamforming supported only by the 5G. So here I'm just going to explain from the standard point of view. But again, the vendors can have different, or implementations can have a can be different from one vendor to another. Okay, I'll give you some ideas as well of how the vendor think about it. But in general, the standard is saying that it's recommended to use a wider beam for the broadcast physical downlink command control channel, uh, to use more wider beam whenever you have, for example, when you have or you want to use it, for example, for a specific payload type or traffic type. For example, you want to use it for paging or system information. So in this case, it's more recommended to use the wider one, because actually allowing, first of all, it's like allowing this kind of narrower beams for the physical downlink command control channel in this case can like be more susceptible or prone into the beam failure because of the multiple switching. You have multiple switching of the beams. For example, here you're assuming that you have 8 SSB beams, okay, being transmitted. So just it will be using, each one of those will have an allocated beam forming. It will be using the same SSB for PDCCH, okay? This is one scenario, and this is used for the common beam forming. So it will use the SSB. SSB means that if it's like one beam, you will use the wide beam. If it's 8 beams, you will use each beam will have a PDCC, will be used for PDCCH. Okay, but at the end, for the common beam forming, can be used for the traffic type, which is called, for example, paging or system information. This is more likely to use the same bandwidth or same wide beams as the SSB blocks, as we highlighted here. Okay, so this can also ensure the complete coverage has been highlighted. But assume now you would like to assume that you have this traffic beams. Okay, the traffic beams usually is more narrower, right, and more sharper, and having a less interference. So in case if you're still using the wide beam for the physical downlink command control channel, so you might face into a situation that you have a good traffic beam, but at the same time you have a problem in the physical downlink command control channel, which can result you cannot decode the information of the DCI, which can result that you cannot get the resources, can result even you have a good traffic beam, you can have a problems in decoding the physical downlink command control channel. So accordingly, you cannot get the resources, you cannot do anything afterwards, even if you have a good traffic beams, right? So this one require more directional beam, and can be done based on the beam refinement concept, which is based on the standard, but it's not really implemented as we discussed in the previous session as well. For example, assume that each of the SSB beams having 4 CSRS. So now the PDCCH can use any of those to be used, for example, for the beam forming of the physical downlink command control channel. So this is one scenario, and this is usually user beam forming. It's not common beam forming, which means, as you know, paging is common, right? Each one is receiving the same message. But user beam forming means for will be dedicated for a particular user, as we highlighted here. So this can be a scenario. So it can improve your, at the very end, improve your PDCCH performance. So it can result also in more better allocation of the resources. How it's being used, and usually that the vendors can do a kind of a dynamic change. For example, it can start initially with a common beam forming, which is a wide beam. Assume that you have one SSB beam, so it will be just allocating the PDCCH beams to only wider one. Then it can decide, for example, for a specific user to do it more dynamic. It can be used to follow the beam forming of the PDCCH, which is traffic beams, for example, using the PMI report. Whenever the user report the PMI report, it can also allocate the beams, same beam of the traffic, or even based on the PMI, it can do a specific beam allocation towards the AV. And this is more the practical scenario where you can find it in the actual networks. The one I'm highlighting here, this is more into the standard, but it's not really followed 100%. Okay, might be by some vendors, but in general, that's all about the two main parts which I would like which I discussed today, which is the SRS in general, which is traffic beams based on SRS or channel reciprocity, and the BDCCH beamforming. And that's it. And that's all about today's session. I hope if you like the session, again, to spread the word and share the knowledge with everyone, and press like and share. Thank you very much, and see you in next video.